another early morning stream, or at least early morning my time stream. And since it's early, I've got another different coffee mug today. This one is my CloudWatch mug, which I don't know if you're all, or if anyone watching is an AWS user, but I am, and CloudWatch is hands down one of my favorite things. So I found a mug from them at a conference a while back, and it's insulated, so it actually works pretty well. And today I've got a handful of problems lined up. The first one is I said it was a graph problem in the description. I think it's actually more of a tree problem. I hadn't really looked at the details too closely when I started. So we're going to do one graph problem, and then I've got probably 3 array-oriented problems lined up after that. I'm trying to focus on that because I feel like that's one of my weak areas right now, just someplace that I haven't spent quite as much time. So that's what we're going to do. Without further ado, let's dive in. And as always, if you're in chat and you need anything bigger or smaller, feel free to call it out and let me know. Be happy to adjust the zoom or make it easier to see if there's anything that would help. So without further ado, let's dive in. So given the root of a binary tree and an integer target sum, return true if the tree has a root to leaf path such that adding up all the values along the path equals target sum. Given the root, if a root to leaf path. Okay. So root to leaf is important because that's something that I got tripped up on in a previous problem, was if you have any single child nodes, that is not a leaf. So this is another node on the path. But if I had a request for, let's just use 4 over here, for 9, then I couldn't go 5, 4 because 4 is not a leaf. So that wouldn't be a valid path. So I think that means that we will need to recurse first. So find the edge and then only return or rather, yeah, so just thinking this through, I think the return for this, so this is probably going to be a recursive problem or a recursive solution, because a lot of tree and graph problems are, but thinking it through, I think the return is going to be true or false to say whether or not you found a valid path. And then one of the parameters for the recursion is going to need to be the sum of the path so far. So as I'm going here, I would say I found 5, and then 4, so 9, 11, so 20, and 2, so 22. And then as I'm going, I would check to see if the current sum equals where I'm at, or equals the goal. If it's greater, then I can stop recursing, because I'm assuming... Oh, no, never mind. I don't have an example with a negative number, which I think would be nice, but so I do need to keep recursing because I might find a negative number that would bring me back into my range. Yeah, target is 0 to that. But if I find a value that is, if I find a node that would give me the path sum equal to the solution, I need to check that it's a leaf. Okay, so let's write that down because I think just saying it out loud isn't always the most helpful. Okay, so we're going to recurse into the tree. Recursion returns Boolean, takes next node. So if the node is a leaf, check if it has the right sum. If the node is not a leaf, recurse. Okay, so I think that should be pretty straightforward to hammer through. So let's go ahead and give it a shot. So private boolean tree node root. Oh, and then I also actually need to take in apparently I need to sneeze. I also need to take in an int target sum. Okay, so that should set up our inputs. Next, let's pause for a drink of coffee so we can think clearly. I should say so I can think clearly, unless all of you are thinking along with me. So now I need to know if the current node is a leaf, and if it is, a leaf, and if the target sum matches current sum plus this, or plus the current node. So let's type that out. So if node.left is null and node.right is null, and cur sum, actually, I think I'm going to update int, and that's not a great name for it, but I'm going to go with it. So node dot node.val. I'm trying to think if there's a better name for it than cur sum. So I think I'm going to turn this into path sum. And then this can be cur sum, because that's really what it is. This is the sum of the path to this node. This is the current sum, or the path sum, including this node. So it probably doesn't make a huge difference, but it helps to keep things clear. So cur sum equal to target sum, return true. So in this scenario, we have found our path, our current path. What are we supposed to return? Return true if the tree heading up. Okay, and then true and false. So it is a Boolean. I was curious if we had to include like the path, or the elements that would make it up, because that always would take a little extra work, but with just this, it shouldn't be too bad. So, and really, I think I'm going to break this out, because if I found a leaf, so here I know that I found a leaf, so I'm not going to wind up recursing. So either way, I'm going to return. It's just a matter of if I return true or false. So if cur sum equals target sum, return true, we're going to return true. Otherwise, we're going to return false. Okay, so I think that's our base case. And then if we get past that, and actually, I'm going to have one other base case up here. So if node is null, return false. And I think that will handle the empty case they're giving an example of here pretty well. So if I start recursing and my first node, or the node I'm on is null, then I'm going to return false from that. And then after that, yeah, I think that makes sense for my base cases. So I was trying to see if there's a way that I could combine this into one if-else block, but I need this null check before I access node.val, and I need cursum later on, so I think I'm going to leave it that way for now. All right, so let's handle the other cases. So then here, I think this gets pretty straightforward. So I already have current sum, and I just need to recurse into node.left and node.right, and we're going to return the results. So has path sum helper node.left, cursum, and target sum, or has path sum helper node.right, cursum, target sum. And I think that should do it, because here we're going to recurse down. If if we've hit a null node, we're going to return false. If we've hit a valid node, a valid leaf node, we're going to return true. Otherwise, we're just going to keep our search going. So let's give that a shot. Path sum here would be 0 because this is our first node. And target sum. And I'm too used to typing hash map, so I typed hash instead of has. And of course, this needs a return statement. So let's give that a shot. Okay. So that worked on one test case. Let's go ahead and try it on the others. That looks good. Runtime is pretty good. So I'm going to submit it again on my stream. I can't remember if it was yesterday or the day before. I was theorizing that Leetcode gives you your own little sandbox, and that your runtime inside of there can vary quite a bit. But I guess here I'm not really allocating any memory. I'm getting, okay, so millisecond, and now I'm at 25%. So Leetcode must only rate you based on millisecond, and there's something about how you allocate memory in there too. It's just fascinating to me that my first run was 40.5, 40.7, 41, 40.9, 40.8 megabytes. So there's a pretty dramatic change. I mean, that's 500 kilobytes between these two. So it's interesting. And now I'm back to 0 milliseconds and 40 megabytes. Okay, I'm going to pull up the next problem and then probably take a drink of coffee here. Okay. So you're keeping score for a baseball game with strange rules. That sounds fun. The game consists of several rounds where the score of past rounds may affect future round scores. At the beginning of the game, you start with an empty record. You're given a list of strings ops, where ops at I is the ith operation you must apply to the record and is one of the following. Sorry, I had to clear my throat there. An integer x, record a new score of x, a plus, record a new score that is the sum of the previous two scores, it is guaranteed there will always be two previous scores. D, a new score that is double the previous score, it is guaranteed there will always be a previous score. C, invalidate the previous score, removing it from the record, it is guaranteed there will always be a previous score. Okay, so let's go through an example because that's involved. So 5 to CD plus. And what is C? C invalidates the previous score. Okay, so we start with 5, and then 2, and then we clear it. So we've got a C. So now we've got 5. And then we've got D, so that would give us 10. And then plus is 5 plus 10 gives us 15. So now the record is 5, 10, 15, and then we take the sum of the previous two, and that gives us 30. Oh, negative. Fantastic. So what are there any constraints? Okay. So this seems like a pretty straightforward iterative problem. I think we're just going to need a switch statement, and then to build out essentially these rules, keeping track of. So I'm trying to decide, because if we keep track of the scores themselves, which we do need to do, we can put that into an array, and we could also create a running total score. And if we have a running total score, that will save us an iteration over the result scores. And I think that might buy us a little bit of efficiency just for the cost of an int, which, let's see. It doesn't actually say, but I think this will be safe to store in an int. Okay, so let's give that a shot. So I think we can just implement this in main, so or in the cal points. So running score equals 0, final list integer. So we'll do this part in an array list. And then I'm going to have to look up how to parse a string or Java string to int. I think it's just like Java string to int. Integer.parseInt. So that's not too bad. Okay, so for I is 0, I is less than ops dot length, I plus plus. And here, I think I'm going to do a switch statement, which I think you can do with strings in Java, probably after Java 6 or 7. So let's just make this easy. Ops final string op. And this is going to be embarrassing, but I actually don't use case statements that much. Okay. So case, switch day, curly brace, case colon, and then break in between. Can I make that a little bit nicer? That's where it wants the indentation. So case, our options are plus, in which case, no pun intended, we're going to need to do a break. And then if it is a plus, the new score is the sum of the previous scores. So that's going to be scores.get scores dot, I think it's dot length for list, length -1, because array lists are zero-based indexing in Java, and then scores.get, let me put this on a new line so it's easier to see, scores.length -2. So this is our new score, and then we want to update our running score. So running, had a typo there, running score plus equals new score. And then we're going to break. And then for case D, what is D? Record a new score that is double the previous score. So int new score equals scores.get scores.length -1. Running score and then we've got a case for C, which is to clear the score. So int, and I am kind of seeing a simplification here where I may not need to run new score or this running score plus equals. I might just be able to store a new score variable and then do that at the end. But for now, we'll just do it in line, which will lead to a bit of code duplication, but I think that's fine. So new scores.get, and then here it's going to need to be multiplied by -1. Or actually, I think I can handle that a little bit easier. So running score minus equals new score. Oh, and then we need to remove it. So Java array list remove method, or yeah. So I need to remove an index, not an object. Remove int index. Okay, so that should be fine. So I should be able to go scores.remove scores.length -1. Okay, and then the last case is the default case. And Java, I think that's just default. Yeah, default. Although I didn't think it was capitalized. Default, yeah, okay, lowercase. So if none of these kick in, then, or does the default case run? I don't like this website. none of the cases is true. So it doesn't run on every iteration or every execution. It just runs if it is the last or the nothing else works. Chat messages go over my. Oh, hi, Rickety Code. Nice to meet you. Thanks for hopping in. Um, do chat messages go over my? Oh, they do. That is top notch, man. I appreciate you pointing that out. If you can't tell, I haven't been doing this that long. So let me move them and see if there's a good spot. Maybe I'll just put him kind of in the top left. So, okay, that should be better. Is that better now? Also, nice to meet you. Thanks for hopping in. Like your handle. Doing some Leetcode this morning. I'm working through a baseball problem. And I think it's actually a little bit easier than I thought it was going to be. Okay. Thank you. You're my QA for this, or my quality assurance tester, I guess. And I might even, later on, I might reverse that because I don't get that many Twitch alerts, like follows or mentions or whatever. But I get occasional chats, so I should probably rearrange that. So I'm working through a baseball problem. The idea is I'm going to get an array of strings, and it's going to be operations, and then the last one is an actual score. And it's not really baseball. It's really just a game where you can get scores, and you might need to use the score from a previous round. So that's the motivation for all of these, the score tracking and then tracking the running score. So I'm at the point where I need to do, and I just looked this up a minute ago, but integer Java string to int. Parse int. Okay, so int integer.parse int as capitalization matters. Integer.parseInt with a capital I. So parseInt up, and then running score plus equals, or I need to save this, int new score equals integer.parseInt for op. And then scores.add new score. Perfect. And then at the very end, we should just be able to return running score because we've kept it up to date the whole way, and we need to track new scores. We really could get away with just tracking like the previous. Well, no, I don't think we can, because we might clear a number in a row. So let's try that. We'll run it, we'll make it working, and then we'll see if there are optimizations that we could think about. Cannot find symbol. Is that dot size on an array list? Size method. Thank you, Java. Arrays, array lists, and strings all have different ways to hand back their length, which is one of those things that I think just means nobody was thinking about it when they were building Java. New score is already defined in this scope. Okay, so I wasn't going to, but I think I'm just gonna track this once, and then at the end of the switch statement inside of the loop, we'll update running score, and then we'll just reset it every time. And then that means that I do need to take new score multiplied by -1 because this is the only one that I did subtraction on instead of addition. Okay. Hit new score. Okay, I need to get rid of it here too. And then I got rid of all of the updates for running score. So let's try that. Also, if anybody... Okay, I'm going to wind up doing some print statements here, but I'm just curious. It's pretty early for me. What time zone is everybody on the chat in, if you're willing to share? And while I'm doing that, let me do some print statements here so I can tell what's going on. I think that'll work. I think scores can just print, or I think array lists have a reasonable toString. If not, then we'll have to figure that out. Okay, so what's my input? Double. So scores.size. I'm questioning if... Okay, so I thought that these were... Man, I had it in my head that scores.size was going to hand me zero-based indexing, or the total number of elements rather than... Or no, that should still be right. Because if I'm... Did I forget? Oh, okay, okay. No, so we're good. That the indexing is correct, but it's here. I forgot to add. So I've updated running score, but I need to set scores.add new score. Because otherwise I don't put that score back in and I can't reference it later on. Okay, let's try that. Okay. Wrong answer, but that's something that we can work with. So what's going wrong here? Okay, so let's take a look. So we've got 5, and then our op is to delete. I wonder if I can put this at a more useful place, like maybe at the end. And then here I can actually print out new score and running score as well. So let's do that. What do you usually do for your job? That's a great question. If you're wondering, language-wise, Java, which is why it's funny that I have to look up all the syntax, but I don't do a ton of just like array list operations in my job, just because when you're writing code that runs an actual service, I feel like you aren't usually adding and removing elements. And then I'm on a, quote, full stack team, so we're responsible for front end all the way back to the data storage layer. But if I can choose, I opt for service layer back. And if you're curious what domain I work in, I'm in shipping logistics at a large online retailer and shipping logistics company. I'll let you figure out or take a guess at what company that might be. How about you, Rickety Code? What do you do for a living? Are you a software engineer or just coding curious? Okay, let's run that and we'll see what's going on, because I must have running score has a capital S. Okay. So we've got 5, which makes sense, and then 2. We clear the 2, so we've got 5, and then D did not work. D was incorrect. So new score is that times 2. I'm hoping that was our problem. Oh, that's awesome. Congrats on graduating. That's always a huge accomplishment, getting a bachelor's degree. I'm assuming, was it in computer science or something related? And also, practicing Leetcode, I think, is awesome. Um, it's a great way to stay sharp and practice your kind of data structures and algorithms type skills. Um, nice. Yeah, I did a BSCS and then an MSCS a few years later, like maybe 8 years later total. Um, but I got a lot out of it. I think if you want to go into computer science and do software engineering, it's uh, good to get some of the classic education. Not that there aren't other ways to get into it. It means that you have to cover some of what you would learn in a BS or an MS or BA, whatever, on your own, and have the motivation to learn it that way. Practicing Leetcode, I think, is fantastic. Um, if you want to go into like a top tier tech company, if you're just interested in getting a job quick, there are tons of smaller companies that would be a little bit less rigorous in the interview. But if you're looking at, the Googles, the Amazons, the Facebooks, those companies tend to be a little bit more rigorous in their interviewing and expect you to be comfortable doing these kind of Leetcode problems. Okay, so while we're chatting, I think I'm gonna take a look at um, another one. I've probably got maybe 20-ish minutes left in what I'm gonna stream before I start the day job we were just talking about. Um, so thanks everybody for hanging out. I'm just doing some Leetcode this morning. Just finished a quote baseball game problem, which is really just kind of a running score problem. And I'm going to take a look at this distance between bus stops problem. But Rickety Code, if you want to talk at all about Leetcoding or applying or anything like that, I'm happy to kind of slow roll this and see if you've got anything interviewee or CSE or new jobby that you want to talk or ask about. So while I'm waiting to see if messages show up in the chat, I'll just start reading, but feel free to interrupt me. I do this partially to practice and partially just to have an excuse to talk to people about computer science and interviewing for jobs. Nah, you can just code. Sounds good. That is the mark of a true nerd, so I appreciate that. A bus has n stops numbered from 0 to n minus 1 that form a circle. 0 to n minus 1 that form a circle. We know the distance between all pairs of neighboring stops where distance I is the distance between stops I and I plus 1. Mod n is the distance between stops number I and I plus 1 mod n. Okay, so if you're at the last stop, you wrap around and it's the reference to the first stop. The bus goes along both directions, i.e. clockwise and counterclockwise. Return the shortest distance between the given start and destination stops. Goes along both directions. Okay, so start and destination is 1, and it's 1 to there. Okay, this is interesting. So this is kind of a shortest path problem where you've only got 2 possible directions. So distance 1, 2, 3, 4. Yeah, 1, 2, 3, 4. Okay. So thinking about this, we could do this really formally with like converting all of this to a graph and going through it, but there's probably a simpler solution just because we know we've only got the two paths to explore. It's positive and negative from where we're at. And I think that we're going to need to go through both of them. But that's still just a linear solution, so I don't see that as being too bad. And it's linear because we're going to visit every node, it's not really a node, but every node in the graph once, because we're going to iterate forwards and then backwards from our start. So I think that should be pretty straightforward. And then is it inclusive or no? So the edges are what have weights. So we don't need to worry too much about that. So let's write out what we're going to try. So one, we're going to iterate forward through the graph, summing edges, iterate backward through the graph, summing edges, test which path is smaller. And what do we need to return? Return the shortest distance. So they don't care about the number of stops. They just care about the total distance. So return which path is smaller covers us there. Okay. So I think the first thing I'm going to do is do a private int get index, or we'll call it get wrapped index. And we're going to need an int array distance and an int final int I. And the reason I want to do this is just to make it a little easier to do the wrapping, because otherwise if I'm starting at 2, I'm going to need to wrap in both directions. And I want to make sure I do this correctly. So if it's a modded index, I need to do return I mod distance.length -1. And I don't think I need to paren this for order of operations because I think mod has the lowest, but I think that'll help. So let's just test that real quick. We need to return 1. Wrapped. And we're going to call get wrapped index distance and 10. I think that should be wrapped. I think I should only have like 4 in here. It helps if you have correct syntax. And I get a coffee break while Leetcode decides to let me have another iteration. Okay. What's our input? 0, 1, 2, 3. Is that right? 1, 2, 3, 4. So there's 4. So 10 mod 3 would be leftover 1. So that does make sense. So what if I do 4? I would expect 4 to be 0. Or no, 4 would be 1. Yeah. Is that correct? 0, 1, 2, 3. I think it is. I don't want to get too hung up on that. So we just you're all going to get to watch me struggle here. So I've got what I need is an int I, where if I go 1 past the value, I get 0 back. So at 0, 1, 2, 3, 4 needs to return 0, not 1. So why am I getting 1? Unless this is incorrect. And I actually need to, because if I turn in 3, I want 3, 0, 1, 2, 3. And if I send 4, I want 0. So I think not -1 is correct. Yeah, yep, I'm hard coding 1 up here. So my output is always going to be 1, but I'm looking at the standard out section, and I was returning the wrong wrapped index. So because this is a circle, and let me know if I'm telling you something you already grasped, but because this is a circle, I need to be able to ask for the last index or one past the last index and have it go back to the beginning. So if I put in an index of 4, and since it's 4 elements in the array, I've got index 3 is my largest index, so 0, 1, 2, 3, and index 4 needs to go back to 0. So I was trying to make sure that I had the logic right in my get wrapped index so that I wouldn't get an off by 1 error. And with that, now that I've got my get wrapped index correct, I think we can actually start implementing. So we'll take out the dummy return there. That was really just in there to let Java compile. And where were we? Before I went down the rabbit hole of correctly implementing a wrapped index. Okay, so I've got a start and a destination, and I need to iterate upwards or from the destination from start to destination, and then from destination back to start, really, or from start going negative to destination. And I think that's a little bit, I think actually going, so because these are always going to be the distances that I have are for node I plus 1, so the distance from I to the next largest node. I think I'm actually going to iterate positively twice, once from start to destination, and then once from destination back to start. So that would get me, in this case, I would go from 0 to 1 and find a cost of 1, and then I would go from destination all the way back to the start. And that way I don't have to do any kind of funny indexing to figure out which distance I'm actually looking at if I were to iterate backwards from start up to destination. So I think this should be pretty straightforward. So for int I equals start to I is less than destination, I plus plus, because here I want to go from the start to the destination, but I don't want to include the cost for destination to the next node, and that would be the index at destination. So int start to destination cost equals 0. And then in here, start to destination cost plus equals distance at I. And then down, or let me stop myself there. So here it's not enough to call this. I need to call get wrapped index. And actually, so what if start is 2 and destination is 1? Because in that case, I would start iterating up, and I'm never going to hit destination. So really, I need to call get wrapped index here as well, but I don't know if I can do that in Java. Because I do want I to start at I, but then every time we increment, I want to see if I think doing this in a for loop is a mistake, is the conclusion I'm drawing, because I don't really just want to iterate from between two numbers, because that might lead me down the wrong path, or if I'm if my destination is smaller than my start, let's see if I have an example like that. No, not with a graph or not with a diagram. But if my destination is 1 and my start is 2, then that's not going to work. So I think instead I want to do a while loop here. And so let's think that through. So int cur stop is going to start at stop or start. And that can just be, is distance always ordered? I believe that it is. Excellent question. And I think, so our stops are from 0 to n minus 1, and distance at I is the distance between the stops at I and at I plus 1 mod n. So I think that just for convenience, they've given that to us where the index of your stop matches the distance at that index. If that weren't the case, I think this would get quite a bit harder. But then looking at an example, so it was 1, 2, 3, 4, and then in the graph, that looks to me like it matches pretty well because I've got 0 to 1, and the cost is 1. So the distance at index 0 is the cost of going from 0 to 1, and then the cost at the last index, so 3, is the cost from going from 3 back to 0. So it's wrapping around, which is the motivation for that mod n up here. Okay. So I think I'm gonna, I've got about I keep glancing down and left. It's where I've got my clock on my phone because I've got one on my computer too. But I've probably got about 8 minutes left in what I'm going to stream today before I wrap it up. So we'll see how far we get through this. I might wind up picking this one up at the next time that I stream. I do export my stuff to YouTube as well, which I probably need to get a link to that in my Twitch channel, just in case anybody ever wants to go back and see a previous or see the result the next time that I do it if you miss the stream. But at any rate, we'll see how far we get through this. And if we die early, that's fine. Or if we can't finish it, then we'll pick it up next time. Okay, so while loop, current stop is going to equal the start. And that's where we're going to get kicked off. So I think here I do need a wrapped. Do I need a wrapped destination? I don't think so. I think that I just want to make sure that my wrapped current stop, so the current stop taking into account that this is a circle, is always so the tricky thing I'm trying to figure out here is how to know to end the loop, because while cur stop is less than destination doesn't work, because if my start is 2, or let's say my start is 3 and my destination is 2, so I need to go all the way around. As soon as I hit the first wrap and I'm back at 0, that's going to quit. But I also can't like just test that they're equal, because I guess I could and turn off insert. So that's interesting. So as long as I know that I'm going to keep going in one direction in the loop, while current stop is not equal to destination, I think actually should work. So let's try that. So current stop, so start to destination cost plus equals distance at cur stop. And then here I want curStop to get wrapped index of curStop plus 1. And I think that actually gets me what I want. And then I'm going to wind up doing this exact same loop. So int destination to start cost equals 0. And there's going to be a little bit of copy paste, which always means that there's a way to optimize, but we'll just start with this for now. And then while curStop is not equal to start, destination to start gets distance at curStop, and then return greater than, so then we're going to return the biggest one. So if start to destination is, or rather, we want to return the smallest one because we're looking for the shortest path. So start to destination cost is less than destination to start. We're going to return it. Else we're going to return destination to start cost. Let's try that. Cannot be applied to the given types because this needs a distance array to figure out the size, to figure out the mod value. Same problem. Okay, output is 1, but I think that's a pretty trivial test case. So let's try it on more and just see what we get. Okay, so that's looking pretty good. Let's go ahead and submit it and see what happens. Okay, so that passed. 1 millisecond is faster than 18% and better memory. If not everybody watching is a Java nerd, then this won't be terribly exciting for you. But to me, it's just fascinating because every time you run, you get a slightly different allocation, which I think really means that Leetcode is doing some stuff inside of the JVM that we just don't see or isn't apparent in this window. Because the memory allocation for this just dramatically changes up and down by, like in this case, what is that, 0.8 kilobytes? Or 800, because it's 0.8 megabytes, 800 kilobytes, which is a significant amount. Like, that's a lot of memory. But again, if you're not a Java nerd, then this isn't terribly interesting. Yeah, okay, so look at this. The last iteration that I had was 39.3 to 40.4. And that's why, as excited as I get to optimize these numbers, I don't think they're quite as meaningful as I would like for them to be. But at any rate, I think that's all the time that I've got for this morning. So I appreciate everybody stopping by hanging out. Thank you to everybody who followed. Greatly appreciate it. And I hope to see you on next time. Have a great day.